And you are of course most welcome. This is Project Euler problem number 28, number spiral diagonals. Starting with the number 1 and moving to the right in a clockwise direction, a 5 by 5 spiral is formed as follows. And there it is. It can be verified that the sum of the numbers in the diagonals is 101. So all those red numbers added up is 101. What is the sum of the numbers on the diagonals in a 1001 by 1001 spiral formed in the same way? Okay, this is an interesting problem because there's so many different ways to solve it. And today we're going to look at 3. So there's going to be a basic brute force method, and then we're going to look at successively cleverer methods until we find one that involves just one calculation. So we're going to look at the brute force method first, and it's a pig to explain, so please be patient. I've drawn this grid. I'm going to have to move it. There we go. I've drawn this grid, which is the same thing on the Project Euler page, just extended a bit. So I've color-coded the numbers that we're actually interested in. Now there's two observations that I need to make here. The first is to do with the interval between the numbers we're interested in. So we start off with the innermost grid, which is just the 1 on its own. Then we move to the next grid, which is 3, 5, 7 and 9. You see the numbers occur once in every 2. Then we move to the next grid and we see the numbers occur once in every 4. Then it's once in every 6 and once in every 8. So as the grid size increases by 1, so the interval length increases by 8. So we're going to code this. So we want a total, and we'll start with 1. We want a grid size. Now the grid size is going to start at 1 and it's going to go up to 500, not 1001, because we're counting one way. So we go 1, 2, 3, 4. So here we've counted 4, but the grid size is actually 8. It was actually 9, but so it's 4 plus 1 plus that 4. So the grid size is actually going to be 500, not 1001. So that's what we're going to go up to. So interval is going to start at 2. And the current number is just going to be the current number in the spiral. So we'll start at 1. Okay, so we're going to keep going up until the grid size is less than or equal to 500. So grid size less than or equal to 500. Right, this is messing with my OCD, so I'll change that. There we go. So while grid size is less than or equal to 500, current number is going to be incremented by the current interval. So current number plus equals interval, total plus equals current number. So it just adds the total every time we arrive at the next number. So what's wrong with that? Oh, I've not named it properly. God blimey. There we go. Right, that's done. Right, another thing to notice. I hope you can see this. Yes, you can. The other thing to notice is that we start a new square whenever the current number is an odd number squared. So we start with 1 and then we go right to form the next grid on this 2. 9 goes out to 10 and then it sort of wraps around. So we've got 10, 11, 12, 13, so it kind of wraps around until it gets to 25, then we start the next square. So every time we hit an odd number squared, we start a new grid. So, and that's when we should change the grid size and the interval length. The interval length will go up by 2, the grid size will go up by 1. So let's take care of that. In fact, I was going to do this all as one line, but I'll have this as a def. is odd is oh dear is odd square n. Oh, not down there. There, good. Right, so that's going to be return n to the power of 0.5 is equal to int n to the power of 0.5, and n to the power of 0.5 mod 2 is not equal to 0. So yeah, return, oh, we don't need that at the end, do we? There, that's all we need. So if is odd square current number, then we add 2 to the interval and we add 1 to the grid size. There, and I think that's all we have to do. So print total. I will get rid of Chrome so you can see the answer, and hopefully this is correct. It is indeed, very quickly as well, because it's not that many iterations. I think it's only about 2000, so yeah, that'll do. Anyway, it wouldn't do if we were doing a much bigger problem. Let's say the first 10 to the 15 sorry, car alarm keeps going off in the distance. What am I trying to say? If the grid was like because at the moment the grid is 1001 by 1001, but imagine if the grid was 10 to the 15th times 10 to the 15th. We would need a cleverer solution. So here comes the cleverer solution. I'm going to get Paint up and running, and then we're going to have a look. It involves arithmetic series and quadratics. That is my clue. Look very closely at the numbers. I will bring them back. There they are. Look very closely at the numbers. They all form a pattern based on a quadratic. So I'm going to get paint. Oh, excuse me. Alright, Paint is up, so you should be able to see something now. Good. I do want Chrome there as well, so we can see the grid. Perfect. Right. Get me pad and me pen. Right, let's have a look at this. I'm going to need Paint up as well. There it is. Oh, I can't see Chrome and Paint at the same time, so we're going to have to change this a little bit. That there, that there. How does that look on screen? Oh, that's fine. Right. Right, just going to make sure. Oh, just going to make sure you can see both sides. Yeah, you can see that. That's perfect. Okay. Oh no, you get over there, and you get over there. Perfect. Right. So I've color coded the numbers for each diagonal, and now we're going to see if we can pick up a pattern in the numbers. So the most obvious one to look at is this northeast pattern, and that's where I'm going to start. So northeast, and we can see that it goes 1, 9, 25, 49, 81, and the next one would be 121, I believe. So let's say we want to find an equation that will give us the nth term in this sequence. So A0 is 1, A1 is 9, A2 is 25, but what is the generic equation for AN? That's what we want to know. This took me ages and ages to work out. I think it's this: 4n squared plus 4n plus 1. 4n squared plus 4n plus 1. I'll just prove that this works. So if n equals 0, then fn is going to be 1. If n is 1, then fn is 4 plus 4 plus 1, which is 9. If n is 2, then fn is 16 plus 8 plus 1, which is 25, so on and so forth. So this is the correct equation for this, for northeast. So I'm going to write this down here. Northeast, 4n squared plus 4n plus 1. Now we've got 3 other directions to look at, so let's do that. We'll go anti-clockwise, 1, 7, 21, 43, 73, and this is northwest. Northwest, 1, 7, 21, 43, 73. Now I should say the point here is that we can just loop over this for different values of n being the sides of the grid, and just get all the values. So it saves a lot of calculation and a lot of faff, because the algorithm, the brute force one, is very faffy, isn't it? So this one here, this has a very similar equation to northeast. It's actually 4n squared plus 2n plus 1. And I'll give you a little proof of that. So n equals 0, fn equals 1, n equals 1, fn equals 4 plus 2 plus 1. Car alarm again. N equals 2, fn equals, oh yeah, that's 7. That'll be 16 plus 4 plus 1, which is 21. N equals 3, fn equals 36. Is that 36? Yeah, 36 plus 6 plus 1, which is 43. So this is the correct equation for northwest. Yes, that car alarm is, you can't hear it, but that car alarm is just, and it must be kids setting it off. The kids around here really are awful. Anyway, let's go. Southwest. Southwest, where I was born, and down in the southwest. 1, 5, 17, 37, 65. You might be able to work out the equation for this from the equations for the other two. I mean, the first thing to note, oh, my pen's not working. The first thing to note is that these are all, apart from 1, just 1 away from the square of an even number. So we got 4 plus 1, 16 plus 1, 36 plus 1, 64 plus 1. But let's take a look at the equations for the other two and see if we can spot a pattern. We see that all that's really changed is we've lost 2n. So I wonder if the equation for this one is just 4n squared plus 1. Let's try it out. N equals 0, fn equals 1, obviously, always is. N equals 1, fn equals 4 plus 1, so that's 5. N equals 2, fn equals 16 plus 1. So this seems to fit the pattern as well. So this is the correct equation for southwest. I'll pop that down there. Now southeast continues that trend. So we're just taking away 2n every time, and we end up with 4n squared minus 2n plus 1. So now we can just loop over these equations to find all the numbers in the various sequences. So let's have a go at that. I'm going to take paint away. I'm going to take Chrome away. There we go. Right, let's have a crack at this. Okay, total equals 1, we'll keep that. And then 4i in range. I think it's 0 up to 501. I'm not sure of this though. So total plus equals, we'll do northwest first. Actually, I'll change this to n because it's going to make things easier. I'm thinking in terms of n, so I'll just change that to n. 4 times n squared plus 4 times n plus 1. Move it down. We'll just copy this because it's basically the same equation with n changed. So 2, 3, 4. So it's 2n, no n's, and a minus 2n. There we go. I hope bidmath holds there, but we'll have a look. Print total. It might have to be print total minus 3 because we're adding these ones. We don't want to add the central 1 too many times, so we'll just check this. Oh, it's added, yeah, it's 4 over, so yeah, this should be minus 3. Bit of a cheat, but we got there. So that's a bit nicer. There is a way to tidy this up even more. We can actually do this in one line. Okay, so let's look at a nice little one-liner that we can use. I'll just write back the original 4 equations. 4n plus 1, 4n squared plus 2n plus 1, 4n squared plus 1, and 4n squared minus 2n plus 1. We can just add these 4 together and make 16n squared plus 4n plus 4. So we'll do this as a list comprehension. It's nice and easy. So I'll have to get rid of paint and bring that back. Right. Print. We want the sum of I. Oh no, it's 16 times I squared plus 4 times n plus 4 for I in range 0 to 501, and then right at the end we want to subtract 3 because we don't want to count the 1 4 times, just once. Oh, what don't you like about that? Oh, undefined name n. Oh god, stupido. Right, there we go, that should do it, and there we are. So that is a nice neat little one-liner. I'm not very happy with it because it's still using iteration. And now let's look at the super duper quick method. So I'll get paint back up and then we will do just that. Right. 16n squared plus 4n plus 4. Now what we're essentially doing here is this. 16 times 1 squared plus 4 times 1 plus 4 plus 16 times 2 squared plus 4 times 2 plus 4. Now we have a formula for this. We actually have 2 formulae for this. Now think back to episode 6. If you're one of the 0 people who watched episode 6, you'll know exactly what I'm talking about. So there is a formula. Let's say we want to find 1 squared plus 2 squared plus 3 squared. We can do that, and then we just multiply the result by 16. We essentially have that bit solved in a single calculation, and there is a formula that allows us to do this. it goes thusly: n times n plus 1 times 2n plus 1 over 6. And then we just take that and we multiply by 16, and that will give us the first part of the equation. Now the second part of the equation is known as a triangle number, so it's 1 plus 2 plus 3 plus 4 plus 5. If you've ever seen the balls in a triangle at the start of a game of snooker, you'll know what I'm talking about, because you have 1 and then 2 more to make 3, and then 3 more to make 6, and 4 more to make 10, and so on and so forth. Again, there's a formula for this, so it's going to be 4 times n times n plus 1 over 2. That's that. And then the last one is just 4 times the grid size, which is 2000. So we have everything we need to solve the problem. It goes like this: 16, I don't know why I'm writing this down again, it's basically this plus this plus this. In fact, I'm so excited, I'm going to code it right now. So it's this bit plus this bit plus this bit. Right. I'll take paint away. So I'm going to call the first bit n squared. I'll do them all as separate things and then we'll just add them together. So it's 16 times, I wonder, actually I'll leave the 16 times bit for later, so we'll do in fact I'm going to set limit equals, oh no, grid, oh, I want a single, I'll just call it x equals 500, there we go. So n squared is x times x plus 1 times 2 times x plus 1, and it's all that divided by 6. There we are. Then n is just x times x plus 1 over 2, so we'll get that in there, divide that by 2, and the free term is just 2000, so we'll just add that on. So print 16 times n squared plus 4 times n plus 2000. We may still have to subtract 3 because yeah, we'll have a look, see if it works. Oh, we just got to add 1, so it's actually 2001. There we go. Slight miscalculation, but we are there. So that's it. That's it for today's episode. I'll see you next time for problem number 29. Thank you very much.